Good afternoon. My name is Ana Maria Leal. I am a sustainability consultant, and I'm happy to be a participant on this Florida's Climate Week. I will be speaking about design for sustainability and circularity, and I hope this session is informative and inspirational to drive some local, national, and global action. Let's see. Okay, so background about myself. I am a former product designer. I started my career at Eastman Kodak Company, designing digital electronic devices. And there I developed a passion for sustainable design, which lead to graduate studies at the Golisano Institute for Sustainability. There I focus my training on electrical and electronic equipment. And then I moved into Swiss company SGS in New Jersey as a senior consultant. And about 2 years ago, I moved to
Hi, Anna. We're
yes.
we're having an issue with the streaming link, so if you'll give us just one quick second, if you want to pause, and we're going to
Okay,
get this updated, and I'll let you know when we can start again. I'm sorry about that. One moment.
don't worry. Okay. Hmm, stop share. You know what happened? We are fixing the streaming link. You can post onto that.
All right, so
There
we
we
are
go.
set now. All right.
All right. Okay. So, all right. So, good afternoon. This is Ana Maria Leal. I'm happy to be one of the participants at the first Florida Climate Week. Um, I'll be speaking today about design for sustainability and circularity. Let me see. Okay. All right. So just to give you a little bit of background about myself and how it led to the topic that we will be discussing today. I am a former product designer. I started my career at Eastman Kodak Company as a designer of digital electronic devices. And then there I developed a passion for sustainable design. Um, and moved into graduate studies at the Golisano Institute for Sustainability, focusing most of my training on electrical and electronic equipment. Then I moved to New Jersey and worked for Swiss company SGS as a senior sustainability consultant. And about 2 years ago, I moved to Central Florida, Orlando area, and started as an independent consultant with my company, AMLY Sustainability. So the reason why I'm speaking about design for sustainability and how my career has led to from design to sustainable design is because, you know, when I was designing electrical equipment at Kodak, we were always looking for improvements to function, form, aesthetics, user experience, usability, materials. This was the traditional design mindset. This is how we were trained in design. And there was no issue, there was no, say, unintended consequences that we could speak about other than it's our design meeting user needs and are they liking the products that we design? that was kind of the main question under a traditional design education. But then I came across a big issue, electronic waste. And this was kind of a pivoting point in my career where I decided to learn more about sustainability and how it affected design. Uh, and when deciding, I was surprised on why we weren't giving thought to what happened after a device is used. And even if it is obsolete or not, but we were just designing more and more electronic equipment. And there was no one really claiming or complaining about all the massive issues related to toxins and rare earth materials or the short lifespan of these devices. So to me, that was kind of an opportunity to jump into the science of sustainability and learn it to inform my design process. And that was the change of my design career because it was breaking the traditional paradigm. I was no longer thinking on only in function, form, aesthetics, user experience, and usability. I was now thinking about energy containing materials, toxins of materials, design for material recovery, life extension, and circularity of materials and products. So it was really a change on how mentality was and then and practice as well. And I guess, the important thing about design for sustainability was not only changing my mindset, but having the tools to measure and make changes. And this is what design for sustainability does. The science informs design decision makers, whether it is an industrial designer, packaging designer, product engineer, or anyone taking decisions at the product design and development. There will be science informing their activities. So what Design for Sustainability was giving me and will give any practitioner is tools and techniques to measure the impacts. A change from thinking a product is a product by components to thinking on systems. A system meaning that what how I design the outside will impact what's inside, and that everything is connected. And if I design for material recovery, I have to make sure that they can access the components. So the systems thinking was another key aspect of design for sustainability. And then the ability to compare designs, the ability to understand what the iterations impacts would be, and how I could make sure that my designs were allowing access to the most critical components, materials for proper management, removal of toxins, and it's giving a boost to the design, making an exciting design, but enabling an additional set of attributes, now improving the environmental profile of a design. And the important aspect is that practitioners could multiply these actions over and over. So to do that, science is providing with frameworks. The frameworks will allow any practitioner to integrate sustainability and circularity in their regular activities. So what a practitioner will do is basically look for a framework like life cycle assessment and cradle to cradle, which are the two main methodologies that I will explain today. Life cycle assessment is by far the most used methodology in the industry because it provides product category rules and product specific rules that harmonize different industries and different types and categories of products. So the life cycle assessment will provide the opportunity to identify environmental impacts like carbon emissions, energy consumption, material depletion, and some other environmental indicators. And then the cradle to cradle is another great methodology or framework that is being used to close the loop, because there is no perfect method. I think to design for sustainability and circularity, one needs to complement the other. So the two methods that I'm presenting today are really the more, I'll say the more stringent and the most beneficial to decarbonize and design for circularity. But there are some limitations with life cycle assessment. It doesn't really help closing the loop, which Cradle to Cradle does. This is why I have selected these two to speak in our presentation today. So just to give you a bit of background about life cycle assessment and why it's so important in adopted mainstream, it is because it has been a framework developed by industry standards. It's a framework or an ISO compliant cradle to grave assessment. And it does provide requirements and guidelines for different industries. It does provide a set of rules that every practitioner should follow to make sure that the assessments are or the products are comparable. And now there are three types of reports. One could be a voluntary label, a self-claim or self-report, and then a third-party verified. So this life cycle assessment falls under the ISO umbrella. How is industry using life cycle assessment? The first thing, as I mentioned before, they are comparing processes and materials. They have the ability to guide product design and create a new set of specifications, identify hotspots, develop carbon footprinting, creating environmental product declarations to create or to meet other environmental program requirements, and also as a business to business document. And the most important is to guide an industry or a company in the reduction of environmental impact. So setting up long-term and short-term goals by using life cycle assessment. So the important part here is, I mentioned the systems thinking. When we design, our designers are typically taught to think about manufacturing in the use phase. That's kind of the most important phases of design activities. Life cycle assessment, it's a comprehensive tool that will encompass from raw material extraction to the end of life. So by that, it's important to know what type of materials and from where the materials are sourced and extracted. How are they manufactured? What not only materials, but also resources, so energy, water, everything that is an input to transform materials into final goods will be considered in the life cycle assessment. And then the packaging, what type of packaging, the size, what happened with that packaging? Is it being disposed of? Can it be recycled? Distribution, what transportation modes are used to distribute the product? And then the use phase, of course, what's the energy consumption, for instance, for electrical and electronic equipment? And the end of life. So is this product disposed of? That life cycle assessment look at the end of life mostly from the recyclability of materials. So this is kind of a limitation, and that's why having another framework like the Cradle to Cradle will kind of take a step further into helping industry optimize. And LCAs, by definition, they are a scientific tool that requires some expert knowledge. So when you conduct an LCA, you kind of, require some expertise, some scientific knowledge. And just to make sure that you kind of get the three main aspects, I distribute how you conduct an LCA in three basic steps. But before these three steps, the one thing that I point is that any life cycle assessment first must have a functional unit defined. So the functional unit is the baseline, the basis to compare products. A functional unit could be how many hours of battery life has your device to provide X number of colors, X number of battery life. So it's really about a unit that help me measure how functional it's my device. And then from that, I will be able to compare the input or the inventory, which is what we base the life cycle assessment on. So data collection, it's the most critical part because we need to create an inventory. And that inventory comes from primary manufacturing information that is collected at the final manufacturing facility. Typically, when there are suppliers, final manufacturers will be in charge of getting information to, relevant to the point where they need to complete kind of a list of materials, weight of of every component, transportation. So everything that's relevant to really have information and data that can create an inventory. And then if there are any gaps, there comes the product category rules and product specific rules from the different from the life cycle assessment. So there are different programs, excuse me, for different types of products. For instance, we have for electrical and electronic equipment, there are some programs to conduct life cycle assessments. So they will provide some rules and some information in case there are not in case there are some data gaps. So you could use these category rules to fill in the inventory and complete information, typically at the distribution and packaging level, at the sort of the end of life and handling of packaging practices, things like that. But we try to work with primary manufacturing data. So the data, of course, has to be collected at every life cycle phase. Then after data collection and inventory, we have a modeling phase, which is basically getting all this data and put it into the expert software. That expert software has a database with materials. And what we do is basically select all the materials in the inventory into this database, from this database into the software, and then select a methodology to evaluate the environmental impacts of products. So every environmental impact is linked to materials. So when you choose a material that has already an attributed set of impacts, and when you run a life cycle assessment, then you have a full set of results for the given inventory. And the last and third step is reporting. Typically, life cycle assessments are used internally because this is where decision makers will have the most advantage to make changes. But sometimes life cycle assessments are mostly used for external report because business or clients require information about environmental impact. So this is where the environmental product declaration comes in place to provide such information and also to show that there is leadership and commitment from the industry to address the identified issues. Of course, this is on a really high level. There are more steps within each of these three main activities. And here you have examples of how industry has embraced LCA, which I think to this date has evolved, and I'm happy to see that this is going mainstream. There is this case study from a company that it's Ansel, the one that you see here is case study material reduction. It's amazing to see that an industry that manufactures protective equipment, which we know is right now in high demand, it's taking life cycle assessment as their main tool to compare and provide guidance for their manufacturing activities. So here we have a case study the company is using life cycle assessment to compare the global warming potential of two different technologies that will be used to manufacture globes. So by that, they will be able to see which one has the lowest global warming potential, and then select the technology that will be more, more convenient for their sustainability goals. Another way that using LCA helps is by comparing a company's products with, other products that. So somehow here it's, CO2 emissions per hour of product use. So comparing energy using devices, lighting bulbs with some computer, and see what reduction of CO2 emissions are as a result of, improving efficiencies and improving the design based on the life cycle assessment results. So there are very exciting, say, uses to this day. And here are some other examples that I had worked as a consultant under Swiss SGS North America. Most of the time, these results or the life cycle assessment were used for eco-design, guiding design specifications, where, as I mentioned before, as a designer, we tend to think from the outside only, from the kind of the aesthetics, the functional, and the experience. And now with design for sustainability, because everything is a system and everything, all the components and parts are interconnected, I could now see what's inside, and then how the external design would affect internally. So guiding design decision makers on things like material selection, components, and how they will put together the parts. Also identifying hotspots, like what is the life cycle phase that could have the highest impact across the life cycle. What is the component that will drive, for instance, carbon emissions from all the parts of a device. Also, what are the materials that will contribute more to the specific impact? And then looking at the whole set of impacts, as you see in this radar chart here, that's kind of like 13, I think it's almost 13 environmental indicators comparing two different design options to actual devices, to make claims that the improvements improved some of the indicators, and some others didn't really improve. So also making note where there are still room for improvement. And then benchmarking, that's pretty much what will drive the next generation of devices. And also LCA is being used for comparing packaging to product ratio. So important to reduce the packaging, but how do we do that? Is there an opportunity to change not only the material, but also the volume? So, all these, I think all these opportunities arise from having information and making the right decisions, and providing information to decision makers. So LCA is really a tool that will give you meaningful results and translate into actionable design activities or strategies. And then creating environmental product declarations. I mentioned it's important. I create tons of them where I declare what materials were in products. This is important because they needed to see the, for instance, the recycling and recyclability of their products. Also to see the percentage of materials, and if there were any issues with any materials that were not highly recyclable and will share a higher percentage of composition of the product. Also reporting on toxicity, and making disclosures of environmental impacts show leadership, and I think it's important for businesses to demonstrate that they are taking action on reporting and optimizing. Okay, so simplify life cycle assessment. So even if, life cycle assessment sounds like a very scientific driven tool, there are also ways that a design practitioner could implement life cycle assessment in a shorter version. So there is a simplified version which will focus on a smaller set of indicators that are more, or potentially are more meaningful for the product. So there are some environmental indicator categories that might not be as suitable for every product. So it is very valid that a company selects a smaller set, focusing on the ones that are really meaningful and will help a company move forward in their sustainability journey. This is a metric that I created back at the Golisano Institute for Sustainability, and it's intended for design practitioners in engineers, because it's not a full life cycle assessment. It's not a full simplified life cycle assessment. It is a metric based on life cycle assessment, but it's giving them the opportunity to complete or fill in data so that they can compare multiple materials quickly in a way that they can make, evaluate multiple iterations constantly, and without having to go through a life cycle assessment. They could be comparing things from a science based tool. All right, so I mentioned life cycle assessment is one of the greatest tools in the methodologies and the framework that has moved forward industry in terms of design for sustainability. But it has some limitations, and one of them is closing the loop. It doesn't really provide strategies that will tell how, after the product is manufactured, used, and disposed of, how we can manage and what will happen with that product. So it's kind of, it will stop at that point and wouldn't really give you answers or strategies to continue, which is what design for circularity does. So by definition, circularity or circular economy is a framework for an economy that is restorative and regenerative by design. And again, here the main focus is design, because without changes at the design stage, then we will be in the same issue of not having fixed all the problematics that we can find to really make materials come back to the production circle. Circularity work in three main principles. The first one, designing out waste and pollution. Second, keep materials and resources in use, and then regenerate natural ecosystems. Obviously, if there is a lower demand of virgin materials, then natural ecosystem will regenerate. And if we keep materials and resources in use, we can kind of have this type of urban mining where we can find materials flowing within the economy. But the key point is that they are safer. So circularity is right, but there needs to be certain conditions before a product is really circular. There needs to be, we might meet certain conditions like detoxifying materials, because I guess the more problem with recycling today is that materials are mostly contaminated by, not only by the food residues that are left, but also by the type of materials and the formulas, also incompatible materials, and of course the lack of recycling stream and technologies to transform materials. But the big issue here is that materials contain some harmful chemicals, and without removal of these red flag chemicals, products will not be truly circular. So another condition is to design for an extended life, because really circularity wants to keep materials being used as much as possible before coming into another use. And then if extended the life is not an option, then design for an intended end of life. So when designers define how they want to define, they have the ability to decide what will be the end of life of the product. And this is by far the most game changer in design for sustainability and circularity. Life cycle assessment will change and reduce the carbon of products, but circular economy is going to make materials come back to the productive circle. So designing for material separation, designing for material recovery, and calling out for all practices like repair, reuse, remanufacturing, refurbishing, which have been around for many, many years, but were not the main goal of design. So for circularity, as for design for sustainability, there are frameworks that will harmonize industry practices, and they are important because they are setting up the rules so that the activities or the activities will really be multiplied and done at various products. So we have the health product declaration, green screen for safer chemicals, and the cradle to cradle. They are all great standards, and some of them will, like the HPD and green screen, will stop or have like advantages and also disadvantages. So the HPD and green screen go to the screening, and then green screen go one step further, which is assessment of chemicals. Remember that for circularity, the key point is to look at how we can phase out toxins. But then the cradle to cradle, I think by far is the most stringent and forward-looking circularity framework, because it goes one step further, requiring optimization. So it doesn't only ask about results of the assessment or screening in flagging materials, but it asks for commitment and actual action to optimize and remove problematic ingredients. So cradle to cradle, it's a multi-criteria assessment for products, and it can lead to a material health certificate or a full product certification. And it looks at 5 different criteria: material health, material reutilization, renewable energy and greenhouse gases, water stewardship, and social fairness. The cradle to cradle framework, it's looking in how we can circle back material, what's biological and what or technical cycle. So for the biological things that we put on and will somewhat go return to be either refurbished or disassembled to become technical nutrients for new products. And the process to get this certification or to really look into optimizing products starts again as the life cycle assessment from an inventory. So we got product data that goes deeper into the chemistry of ingredients. It goes down to even 100 parts per million or 1,000 parts per million. And then a screen in the inventory. And then if there are no substances of concern, then the product can move into assessment. The assessment is done by a third party. And then an assessment report is provided to the Cradle to Cradle products program, where they have technical experts reviewing the assessment and granting this manufacturing company. Is the optimization. Like I mentioned, it's not about just reporting an assessment. It is about how changes are done. So manufacturers have to commit to make a change at any point of the, of course, criteria that is assessed under the program. And by far, substitution of red flags and issues on any of the 5 criteria that are assessed under this program. So here I give a little more background on how the criteria works. So it's split into these 5 categories: material health, no red flag substances, substitution to safer ingredients, circularity, design for circularity. The circular strategy has been in place. It's not that I say, well, I design for circularity. There must be a strategy, and that means that there must be a technology in place somewhere in the world that will make the product being circular and allow for the material circularity or recovery, and that materials have to be compatible with that technology, with existing technology. Also looking at energy and carbon, the use of renewable energy sources at the final manufacturing facility, and what are the greenhouse gas emissions associated to the manufacturing of the final product. Same for water stewardship, impact to water reservoirs from the use in disposal of substances from the manufacturing. And this is one of the good frameworks that is looking at social fairness. So what are the supply issues associated to manufacturing of a product? Is there any child labor issues? And it's looking at tier 1 suppliers, and not only looking at them, but helping suppliers to conform to labor standards and resolve issues across their practices. So it is a good standard into, providing support to the supply chain as well. Any manufacturer interested in this program will have to recertify before the 2-year mark, which is important because that it demonstrates that there is real interest, and there have been changes in commitment to continuous improvement. So there are no I think that there are no changes from one day to the other. It takes time, and that's why it is continuous improvement. And the Cradle to Cradle has been adopted by other standards, for instance, a LEED. So a product that is certified under the C2C program, it's eligible for materials in optimization credits under the LEED program. C2C has also an advantage because it aligns the restricted substances list of retailers like Target and Walmart. So any program or any manufacturer interested in complying or declaring, about the health of their materials and their ingredients could be using the C2C report or assessment report to demonstrate commitment and demonstrate compliance with these retailers list. And then C2C has a material library to choose products from, which I think is unique. But most of these circular economy frameworks will provide a public repository or a library of materials, or having the opportunity to select materials that are already assessed and have already optimized. So as a consumer, products of interest and purchase them in the market, because you already know the C2C. You can know that they have done their due diligence to remove some of the toxins or are on their way. And you can see the different scores. The highest score is gold. And I think that's, a huge commitment to improve things, not only on material health, but also circularity, social, water, energy, and GSG. And this is a project that I really enjoy working on. And I think I learned things that, as a design practitioner and a sustainability expert, I not only look at sustainability aspects, but I think that these frameworks, especially the Cradle to Cradle, has providing, or circularity has providing an opportunity for other industry changes and positive changes. Because my takeaway from this project is that we could invest and we could find technological innovation. So Cuties is a diaper, and diapers are, by nature difficult to recycle because of contamination, of course. But looking at ways to move this project forward and trying to find who was recycling diapers, we find out that the largest manufacturer of diapers partners with a company in Italy that has developed a technology to sanitize and separate the materials of diapers. So because of that, I think circularity has fostered technological innovation and is facilitating producer responsibility, because now companies could think on ways to recover products and recover materials. And then that has promoted also the ability to clean the supply chain by using more safer materials. And circularity is not only for keeping us away from throwing out more products, but also from keeping us safe, because we are removing all these problematic materials and ingredients. So I think this project I really enjoy, and I learn how circularity is also helping in technological innovation. And I guess with that, I want to thank you for attending today's session, and I want to finalize with reminding you that design for sustainability and circularity, it's a way to measure the impacts that require life cycle thinking and systems thinking. And we need to detoxify products to be able to recover their materials, but we have to design with an intended end of life if we want to keep materials in use. So let's see if we have any questions, and comments from the audience. See, anyone here? Let me see. Okay, well, it seems like we don't have any questions. So I think we are good, and I hope that you have enjoyed and find this session informative and inspirational for some local change. Thank you.